ToTP or not ToTP? That's the question.
Well, yes, of course. ToTP is awesome. It's better for security. Users are stupid. Passwords suck, and people get it wrong all the time. And Google does it, and you just use your phone these days. Yes, awesome. You should absolutely use ToTP. It's a great idea.
Okay.
Yes.
I'm convinced. Are you convinced? Yeah? Okay.
Okay, well, thank you for coming. I heard some
Let's have beer
drinks,
and
so that's
pizza.
good. It's a bit early for pizza, I think. We can start with the beer.
Yeah, well.
Or
So what time?
you guys came for the beer, right? Not for the presentation.
At what time is the pizza?
8 o'clock.
8 o'clock.
8. Ooh.
Oh. What are we going to do until 8 o'clock?
Let's play Canasta.
Or tell them about ToTP.
Well, do you guys want to hear about ToTP? Or I guess we could. You wanna?
Yeah, that's all.
Think you can?
Let's start again.
Yeah.
Yeah.
I guess we can. So where should we start?
Let's start with the introduction.
Let's start with it. That's a good idea.
Yes. Hello, my name is Rolf Bilker, and I'm an actor. But as you know, I'm a very bad actor, and to support my daily expenses, I have to work a daytime job at Top Desk. I make service management software, and we have offices here in Kaiserslautern, in Budapest, and in Delft. And if in the future you're looking for a job, give us a call.
And my name is Henry Zwitserloot, and I write plays, but you know, it's hard being an actor, so I do have a side job. I work at Zorg Order, where I crunch lots of data for Dutch general practitioners.
Yeah, you also might recognize us from wearing these suits. We are also the boilerplate busters. We are the lead developers of Project Lombok, and that's a tool which allows you to remove lots of boilerplate from your Java code. What's in a name? That which we call a rose, by any other name, would smell as sweet.
What is in a name? What is in a name? ToTP. ToTP stands for time-based one-time password. This is fairly confusing and mostly uninteresting, but we will get to it. But you may also have heard this referred to as two-factor authentication, or TFA, or maybe you've heard of multi-factor authentication, MFA, or even authenticator, or dongle, or these are all the exact same thing. MFA, TFA, TOTP, all means the same thing. So what does it mean? That is a TOTP device.
Yeah, who has one? Yeah? Who has seen them before? Yeah. So what it is it's a dongle you have typically on your keychain, and every 30 seconds a new code shows. And there's 4 bars over here, and they tick down, and then you get a new code.
And it's forever. It
Forever.
doesn't turn off, it runs for years.
So it's great because then some server can know that you have access to this code.
And this is one for, RSA makes these for mostly corporate logins. This is World of Warcraft. This is the actual physical dongle, and I think Blizzard was handing them out at various conferences where you can order one for like $5. And that's been going on for over a decade. Like Gmail has one, there are lots of these, and then so you just get like a huge keyring, and then you just put all your dongles on it, like 30. It looks really awesome when you're just walking around.
No, I don't like it.
But
So can't you just use one dongle and use that for different applications? Different websites, like I have one and that's me.
But then Blizzard can also read your email. That's not really secure.
Right.
So you do need 30 dongles. But it's cool. Keyring, you look
Can you give me a virtual dongle on something that I already own, like one dongle virtual machine?
Well, what could you possibly own that could run virtual dongles?
A smartphone?
A smartphone? Well, nobody has those. Actually, I think these days everybody has a smartphone. So here's an app. This one is made by Google. It is often called Google Authenticator. It's a standard. Google didn't invent it. They just implemented this particular standard with this app. And there are many others. And these are, so what's going on here, you have 2 dongles. These happen to be both for emails. But still, this pie chart just ticks down 30 seconds, same as the separate dongles. And you can add as many as you like. So instead of walking around with a keyring with 30 of these, you can add, if you like 30 different virtual dongles to this one application. So this one is, I mean, obviously Google makes this. If you log into Gmail, you enter your username and password, but then you get this. You have to prove that you have the dongle, or in this case your smartphone.
Yeah, also a lot of other applications or websites have support for this. For instance, TeamViewer or Dropbox. So they all implement the same protocol. It's an open standard, and the Google Authenticator is one of the apps that provides you with the numbers, but there could be other applications.
Oh yeah, there's Authy in there, many in there. And there's even an app for Microsoft Windows Phone, so amazing. Right, but what is it? Now, I did say ToTP, that's more or less the usual name for it. That's kind of a weird name. I like the MFA, TFA name more. But what are we talking about here? Two-factor authentication, multi-factor authentication. What is a factor?
Well,
right. Well, if I'm a user, I go to a server, and the server doesn't know who I am. So I say, well, I'm here. And the server goes, yeah, well, I mean, lots of people know your username, I don't know who are you. So I need you to authenticate yourself. You need to prove that you are you. And then I go, well, I'm me because I know the password of my account. And then the server goes, well, they say that they are Reinier. They know the password of Reinier. That's probably Reinier. And then I can, for example, read my email. So there's one factor here, something I know, my password. And that sounds reasonable.
Okay, I have a question to the audience. So, who of you ever logged in on somebody else's computer or a public computer? Okay. Who has ever used the same password for different applications or accounts? Okay. So the fact that someone else knows your password does not really mean that you are you. On the different computer, there could be a keylogger installed. Maybe you have used it over HTTP and someone in the middle could have stolen your password, or a bad application really tries your password that you register with them for accessing your mail or another application. So something you know is not really that strong, it could be stolen.
Well, it's useful, but it's not enough.
It's not enough.
We need more. So we add another factor. We go from something you know to something you
have. So what is something you have? In this case, something you have is not a skull, but it's the code that changes every 30 seconds.
Well, it's the dongle.
It's the dongle, yeah.
The
dongle or your phone. So you can prove you have access to your phone or to your dongle, and it's recent access because the code changes every 30 seconds. So you have access to it now, not a year ago.
And the whole idea for these virtual apps on the phone is these do not get backed up. Because the idea is you can unlock your backup with a password. It's only on your phone, and your phone only. If you throw your phone away, the code goes away, and then you lose the proof. So it's very much about you know your password, that's something you know, and you have a dongle or your phone. And by having both, that's much more secure than having just one of these.
Yeah.
And this doesn't, like the dongle doesn't replace a password, it's an addition.
So it's something you know, it's something you know combined with something you have.
Yeah.
So that's good enough, right?
Yeah. Well, I mean, TFA could also stand for three-factor authentication. It's kind of convenient. I've heard of a third.
Oh, yeah.
I've heard of something you are.
Okay. Do you know what it means?
It looks like what is it?
It is like something that is intrinsically you, like your iris scan or your fingerprint or your DNA.
That sounds kind of awesome. It's like Mission Impossible stuff, James Bond. Let's do that. That sounds even better.
No.
But James Bond, Mission Impossible, awesome. Why not?
So the problem with your fingerprint or your iris scan or your DNA is you cannot change it. So you can change your password easily. You can change your device. You can say, don't use this one. Give me a new phone or give me a new dongle. So that's easy to change. But changing your fingerprint is pretty hard. You can remove it but not change it. Changing your DNA, also pretty hard.
So your argument is like my fingerprint's gonna get stolen.
Yeah, that happens.
That sound, come on, that does not happen.
Yes, it happens.
No, you've been watching too many movies.
No, it really happens. Don't use it. It happens.
No, but come on, it doesn't.
So here we are here in Germany, right? And there is a hacker club called Chaos Computer Club. And they stole some fingerprints. They stole the fingerprints of a woman called Dr. van der Leyen.
Isn't that the current Minister of Defense of Germany?
Yes, she is.
Is that the finger on the button?
Yeah, that's a fingerprint, and that's the finger on the button.
I hope not.
I hope it's better secure than by just using a fingerprint.
I'll stick with something you know and something you have.
Yes.
Well, I mean, we could use it, but maybe we should consider it a username and not.
Yeah, that's okay. Use a fingerprint to say, hey, this is who I am, and then use the password and other means to authenticate that you are who you are.
So the security lesson here is if you can't change it, it cannot be an authentication.
It cannot be, yeah.
But how do we change it to?
Get a new one and unregister the old
So
one.
just get a new oh, yeah, okay, fine. You have convinced me.
Okay.
Maybe we should make something to remember this by. Maybe we should make a selfie.
That's a good idea.
That is good.
Make a selfie.
Yes. I think my phone's in my bag. Can I just borrow yours?
Yeah, that's fine. Here it is.
Alright, so there's a problem here, right? This is Roel's dongle. This is something he's supposed to have, and he just gave it to me, which is a dumb thing to do. Do you trust me or something?
I trust you, Randy.
That's.
You look trustworthy.
You said you're a bad actor. No. So there's a wise lesson here. Users will continue to be idiots. This is not a magic bullet. It makes things better. It doesn't make things perfect. There is no perfection. But hey, we can strive for better. You still need you're still going to run into users that lose their account and that somehow get hacked, etc., etc. But with ToTP, it'll be less likely. It'll be a lot easier for your users to secure their accounts. But it's no magic bullet. It's just an improvement.
So what we've seen so far is what are the problems with multi-factor authentication, and we gave you a bit of explanation on what are the two factors that we think we should use. Act 2. Friends, Romans, countrymen, lend me your ears.
I think it's time for. Let's see an actual ad. Let's start an actual ad. One second here.
Did you delete the database?
Yes, sir.
Good.
Here we go. Alright. I'll make this large and let's have it. So this is a demo app, just to show you what it's like. Is this? Yeah, this should work out. And this demo, normally, let's say this is the front page of Facebook, right? Because that's something quite as nice, but generally speaking, I'm not logged in right now, and I'm gonna go through the whole process from scratch. So I'm Hamlet, and I'm going to make an account on this website. So I'm going to sign up. And we've seen this before, we've done this for decades, right? You want to sign up, well, you pick a username, so I'll be Hamlet, and pick a password. Yorick, why not? Poor Yorick. Alright, we'll create an account. Passwords need to be 8 characters long. I probably need
So, I'll stand. So, what are the restrictions typically of passwords? So, what does the password look like?
It's belong.
At least we have a minimum length, say 8 characters. What else?
You have to track numbers.
You have to add a number. Okay, no, stop with the number. So, if I have a password called Yorick, so how do I put a number in there? What do I do?
1
Where?
at the end.
At the end. Yorick 1. And now I need
much better password. Much better.
I heard someone say special character. So, what special character? Exclamation mark. Yorick 1 exclamation mark. And we need to have an uppercase letter, right? Where do we put it?
Start first.
Start with it. So, the password is going to be capital Y, Yorick 1 exclamation mark.
How did you know? It was supposed to be a secret.
Yeah. But this is what users do, right? If you put constraints on the contents of the password, they're gonna be very predictable. And that does not add a lot of security.
I know, we'll just say they need a minimum password of 20 characters, and they need 5 different special characters and 8 numbers and 4 capitals.
Good. So what do people do if they have a password like that? They forget it, or
Write it down.
write it down.
At which
Good.
point we're back to a single factor, namely the post-it note you wrote it down on. So that's not great. There's no such thing as trying to un-idiotize an idiot. And we've all been idiots one time or another with passwords. So that's a problem. Still, so we've got this capital Y, Yorick, exclamation mark 1 going on. And I can't type. Alright, now normally, my account is created. I mean, if you want to ask for other stuff, that's fine. This is just a demo episode, we're not going to do that. But normally I'd have my account right now. Maybe verify my email address, but again, we've been doing that for years. But here, something else is happening. Here we get the prompt of, let's try to enable two-factor authentication. And specifically with the virtual app that we showed you on the phone. I know you can get this for Android, iPhone, Gmail, there are even custom devices you can get. But we do need to set it up. And an easy way to set it up is QR codes. Now the idea is that I just get my phone out, start the Google Authenticator app or Authy or any of the other ones, and I just scan that QR code. And that sets up my phone as the dongle, basically. Now, I could do this right now, but because this is a demo, it will actually tell you what you would see if you got your phone out. Makes for easy demoing, right? But there's something else going on there. There are a couple of other codes we can try, because remember what ToTP stands for? T stands for time-based. And one of the things about ToTP is that your phone has to have the right time. Well, it has to have the same time as the server. Now let's assume the server has the right time. But does the phone have the right time? Now generally speaking, sure, most phones, most smartphones these days get their time from the network. But it's possible some user has misconfigured their phone, wrong time zone, etc. So let's try it, right? Let's actually try, see what happens if I type in the wrong code because my phone is on the wrong schedule. And we're actually going to be very friendly to the user, because the biggest problem with users is if you just throw in their face, it's not working, they give up, or especially if ToTP is optional, which is on virtually all services optional, they'll go like, this isn't working, and then they won't add it, which is bad, because we like the security of multiple factors. So when you can be nice to your users, and that's what we're doing right here. So we actually say, your clock is off, your phone is ahead by 58 minutes and 30 seconds, and you're going to have to fix it before we can continue. And generally speaking, this will probably be daylight savings times. We even suggest turning on network time, etc. Now, let's assume the user fixes it and types in the actual correct code. And then that's it. Now they have their account, they're logged in. Right? There's absolutely no point in telling somebody to log in again after creating an account, which lots of sites do. It's not app security, don't do that. Be friendly to your users. Alright, now, let's go back to the
What was this QR code?
Exactly. So,
It
that
was a magic dot pattern.
QR codes just store text. That's really all they do. It's an encoding of a text. The string can be a certain length, but no longer. That's all it is.
Okay.
But you probably wonder what's in it.
Yes, what is in it? Well, actually, I know what's in it. I can't
Oh,
tell them.
You can explain. That is it.
Yeah, so what is in it is a special URL or URI. It says it is for OTP out, one-time passwords, and then it says I'm using time-based OTP, and then this is something to identify who it's for this paper.
Well, that's useful, right? Because if I have 30 things in my phone, it would be really annoying if it just says double 1, double 2, double 3, double 4. What I want to see is Gmail, and then probably my account name, or something like World of Warcraft, and then my character name. That would be much more convenient. And that's what those my site name is for, right?
Yes, and then here is the secret, because the server and your phone need to know the same secret, because that's how they can check if you have access to the device, and then you repeat the name for the display purposes again.
Yeah, that's so. I don't know why that's in the spec.
So this secret is.
It's pretty. I'll try to pronounce it. Or
Yeah.
maybe not then. Yeah, that secret. What's going on there is that it's 80 random bits. It'll be enough. We'll explain later why 80 is fine. And it's just encoded with basis 32. And now where do you get these random bits? From random. If we're programming Java, from secure.
Yes.
Right? But it's nothing special, not a password, just random bits.
And how do the server and the client know if they have the same secret? Well, that part is actually pretty easy.
Yeah, because that is the secret, right?
Yeah. Don't let the secret go out.
Well, you can let it go out to your phone.
Yeah.
But it shouldn't go beyond your phone.
Yeah. And how the protocol works is it takes the current time since computer Jesus.
Computer Jesus.
Yeah, computer Jesus. That's 1970.
Computer Jesus was born January 1st, 1970. We count the milliseconds since the birth of computer Jesus.
Yes.
In not time zone based, just since in technical geometry, right?
Yeah, UTC. And we divide it by half minutes, and then there's some number. We call it tick.
Yeah. And then we have the number of half minutes passed since the birth of computer Jesus.
Yes, correct.
Right?
And then we take a secret, and we take this number, and we hash it. We scramble the bits.
It's just a bunch of SSA1.
Yeah. And then we only take the last 6 digits.
And those are the 6 digits on your dongle, on your phone,
Yeah.
etc., etc. Now, very important about this bit of math is the only thing that only my phone knows and nobody else knows is secret, right? Because everybody knows the current time. So if that secret got out, then they can produce the same codes that your phone is producing. So when you're signing up and somebody shoulder surfing you just makes a picture, right? Or we have 2 video cameras here, then this is not working. You should sign up for this stuff at home.
Yes. So also the code changes every half a minute, and you have the secret, and the server has a secret, and we just use the time as a variable. So using the verification, the server could just go over some numbers. Like a 25-hour window or something like that, a full day ahead and a full day back, to check, hey, which is a number that matches. And if it is the current time, then it says, okay, your code is correct. But if it is off by an hour, as happened, then it knows that it is off by an hour because it knows, well, it's not this tick, this half a minute, this is a tick in the future.
Yeah. Now, let's see that in practice, right? I just create an account as Hammond, I log out, go do something else, I come back, I want to log in again. So I'm going to log in, and this is same old, same old. This is what we've been doing for 20 years, just username and password. We don't mess with ToTP right now. Just first we need to know, we do it one factor at a time. So I'm going to prove that I'm me, that I know what I know. So I'm going to type in capital Y or my very, very secret, very big password. And then it says, hold on, we can't log you in yet, because you've proven one factor, but we want 2. So we need to confirm your login with the device. Now here, we just have to type in the code that's on the dongle, the 6 digits. Well, I will try. This will be on my phone. And we're logging. It's easy as that. And then I go and leave again.
Okay, and what happens if you type a wrong code? Or
well,
a future code or anything?
I don't know what's going to happen with that.
So what did you just do? Can you show it again?
Okay, I log in with my password, and then I type in my code, and then I'm in, and then I'll log out again, and then I can leave, and then everything's fine.
Hello, I am Hamlet.
You don't sound like Hamlet.
I can prove I am Hamlet.
You don't look like Hamlet.
I can prove it. Let me log in.
You kind of look like Iago.
Iago?
Yeah, the parrot from Aladdin.
No, I'm the bad guy from Othello.
Aha!
Oh, no, I'm Hamlet. I can prove it.
I really doubt it. You are Hamlet?
Yes.
No, I don't.
Yorick, capital Y, Oric.
No.
One exclamation mark.
Why did
See, I am Hamlet.
Aha!
Okay, the code.
You don't have my phone.
The code is 296508.
Were you shoulder surfing when I presented the code?
No.
So you guessed it, huh? Alright.
No.
Aha! It doesn't work.
Yes. The correct code is 0 0
Mm-hmm.
0 0 0 0.
That's 7, so I got it.
6 and 6 zeros.
6 zeros. So,
Yes.
well, before I try that one, what happened here is, it was the correct code, but it was already used. And one thing you really have to protect against, we just said, people can shoulder surf, which shoulder surfing is where someone's just behind you and just looking at what you're typing. We can have keyloggers. Right, I just typed in a password, so if somebody has a keylogger, they already know my password. If I also type in the code, then they also have the code, which is going to be valid for, a couple of minutes. So that's not good.
Yeah, that's also
The
why
idea
it's
is-
called one-time
Yeah,
password.
so the O in ToTP stands for one-time password. The idea being it is valid one time, which is when I log in. Now, Hamlet, Iago over here, tried to log in again, and it isn't TTTP, it isn't time-based two-time password. It's one-time password. So you have to remember which codes were used. And now you're already thinking, oh no, now I have to create a database table which is going to get humongous. I have to store all the codes I ever used. No. Remember, it's time-based. So we take the current time, divided by 30,000, etc., 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 and that's the code that we use to say, okay, he has the right code. The only thing we have to remember is the last timestamp that we use to confirm that Hamlet is Hamlet. That's just one number. You don't have to remember all of them. So the idea is, I put in my database, the last time this user logged in, they used the code that goes with time, and then that code, and all previous codes, no longer valid. And that prevents shoulder surfing Iago over here from logging in. But Iago isn't done yet, and I hope this is a guessing game.
Yeah, and the next code is 000001.
Right, but shall we try this one first? You can get to your 000001. I think you messed that one up. That wasn't 00000. Bad enough. Now what's going on here? Let's say, what are the odds, right? 0000001. It's never going to be good.
Yeah, it looks like the chances are 1 in a million because there's 6 digits. So once every million codes is going to be correct.
But it's actually worse than that because it's 1 in about 200,000. Why? Well, remember, we divide by 30,000 milliseconds, so that's 30 seconds. Every 30 seconds, you get a new code. Now, it's a bit crazy to demand that my phone is within about a second of the server, because, sure, we have network time protocol, but they tend to drift a little bit. Like, your phone can be off about a minute and a half. That should be all right. So how do we solve that problem? And the solution is you don't check one code, no. You check if the user entered the current code. But if they enter the code of the next 30-second block, that's okay, that's close enough. If they enter the one after that, fine. If they enter the one before that, also okay, and even the one before that. So there are a couple of codes that are okay. And now the bigger you make this window, the more clock skew you can handle, but the more codes are valid. So generally accepted, and the one that our demo does is 5 codes. So that's a full minute ahead, a full minute behind, and our current window. But that's 5 codes still. So if there are only a million codes, there are only a million different combinations of 6 digits, and 5 are legal at any given time, he would have to guess about 200,000 times in order to get in. Now, we do get beer at 8, so we don't really want to wait for that. But there's a little bit of a problem here. I mean, Iago is from the older days, but computers can guess pretty quickly. You can get through 200,000 requests in seconds at most. So if somebody starts guessing, we have a big problem, because they're going to hit it eventually.
So one solution that we've seen in other applications, especially for password guessing, is say, well, we're going to limit it to 10 tries. And that could make sense. And after 10 tries, we lock the account. And if the account is locked, you need to contact your system administrator to unlock it again.
Now, that sounds like an out of circles. Like you can't do it to passwords, because then if I know his username, I can just enter 10 random passwords, lock you out of your own.
Yeah. So that's one of the problems, is it's easy to lock someone out.
Well, it's not that easy, because you can't get to the prompt until you know the
You
password.
first need to know the password. And but the other thing is, if you allow for 10 codes, well, 10 out of 200,000 is
20,000.
20,000. So
It still sounds like a big number, but if I get my hands on the username and password database, then let's say you have 100,000 users, then I'm going to log into about a fifth of them, or at least about 5 of them, which is still 5 users I get to log into. Still not great. Also that whole lockout thing, okay sure, now you've locked them out, what do you want to do? I mean, if it's a corporate intranet, then the user will just go to tech support and ask, hey, can you reset my account? And it'll be fine. But if you are Apple or Google or Facebook or some large site, how do you confirm that somebody is who they say they are and it's not the hacker who's trying to hack the account? You can't ask for the password because they already know that. And if somebody knows the password, they might also know stuff like mother's maiden name. I mean, you've read the stories. That's not the best of solutions. It would be great if a user could just prove that they are that they know what they know and that they have the device without having to call someone. And there is a way to do that while we still stop Mr. 000000 over here, which is, we don't ask for one code, which there are only a million of those, we ask for 3 codes, because that's a trillion. And
3 consecutive
yes,
codes.
3 consecutive. You have to, this is annoying for users, have to wait about a minute to a minute and a half for their phone to go show code, type it in, wait 30 seconds for another one to show up, type that one in, and then wait again another 30 seconds, and then type that one in. Now, one nice thing we can do here is, because you enter 3 codes, because the odds are abysmally low, you can guess this, like, even if you have a really fast server, it'll take hundreds of thousands of years to randomly look into the right code, or one of the 5 right codes. We can be nice again, right? So let's try and type in something completely wrong here. We're again going to be nice, right? So here we say, look, your phone is off by 2 hours, 25 minutes, 30 seconds, something's going way wrong here. But we can't say this, because the odds that he would randomly guess any legal code in the next 24 hours or the previous 24 hours, so that's 48 hours times 60 minutes times 2 every minute, that's still nothing compared to the trillion different numbers that are legal. So we can be nice. It's not good enough to clear code, but we can be nice and tell them what the problem is. Again, if it's okay, if it's not a security leak, be nice to your users. Now this time I'm going to actually type in the correct codes. And normally, so I would get out my phone, it would currently show 1511105. I'd wait 30 seconds, it would show 340971, I'd wait 30 seconds again, and it will show this. And now, when we do this, you log the user in, and we're cool. Now, another thing is, let's try this one more time. And I'm just gonna, right now. I tried, and I failed. Now, do not store this failure to enter the code in a session, right? What I cannot, what's a really bad idea is if you create another tab here. I'm just going to give this another shot. It'll jump immediately to the enter 3 codes. Now, if you just went back to just enter 1 code, you stop nothing, right? Hackers have access to millions of IP addresses. You can buy a bot with like 1 million different hacked computers on the market for relatively little money. So you have to store in the database, hey, they messed up.
This account is
This
now...
account needs to enter 3 codes in order to unlock it. And when they do, you can unlock it and you know, they can just enter 1. Right.
Recap?
Yeah.
So what we've seen is, be nice to your users, don't put weird password constraints on them, tell them what's wrong. Actually, idea. What happens if I use a wrong password? Wrong username?
Oh, that's good. Let's try it out. Well, if I try and enter the wrong password, I get the wrong password. But if I try to log in Iago here, it says the username doesn't exist. And a pen tester might go, that's insecure.
Yeah, some pen testers or security specialists say you should not tell the user if they use a wrong username.
First
or
wrong password.
wrong password.
Who's heard of this?
Because you are leaking information.
Who has heard of this before?
So now it's possible to get a list of usernames, because I can just brute force this one, and then you get a user list. Well, I have news for you. Usernames are not a secret, and I'm going to prove it. So, can I ask you? You work at a company, right?
Yes.
Yeah. Is your username in any way related to your personal name?
Yes.
Do you have a LinkedIn account?
Yes.
He's a colleague of yours, right?
Yes.
If he knows your name, does he know your username as well? Can he predict your username?
Yeah.
And your email address probably as well? And you're on LinkedIn?
Yeah.
So and the whole world can have a guess at your username?
Yes.
Can you change your name, please? So, what I said before is, if you cannot change it, it should not be considered a secret. Usernames are not a secret, because you're not changing them.
Or we could make this a lot simpler. Let's say I want to make a list of valid usernames for Twitter. I could try and log in with a bunch of accounts and I'll keep getting the wrong username or password, which is actually what happens. Or I go to the sign up page, I try the name, and it will say, with a nice spiffy Ajax call, that username is already taken. What the heck? If you're just going to tell them that the username is already taken when you try to sign up, why are you being vague about, maybe the username doesn't exist, maybe the password is wrong?
So,
doesn't add up.
we were doing a recap here. So, be nice to your users and give them information, but not give them information without thinking about security. And in this case, what we said, if the user provides 3 consecutive codes and they happen to be correct, then it's okay, but not right now, but maybe a few hours from now, it's okay to tell them your clock is off, because you have given enough information for us to allow to tell you that you're probably in a wrong time zone or data saving time.
But think through the implications, or use this library, which we'll get to at the very end, which I just thought of for you. For example, if I wait long enough, that code is no longer valid, right? It's time-based, we have a limited amount of time for that code to be valid. If I'm late, and about 5 minutes late, it's no longer valid. If I were to try that, it will actually say, hey, you waited too long, it's been 5 minutes, it's nice enough, but it's nice, but it will try to stop hackers, right? So what it will do is it will tell you what's wrong, but it will then ask you for 3 consecutive codes. Right? Because it's possible that somebody looks at their way and guessed it at random, and we have to stop guessers, so then we ask for 3, but we be nice when you can, and when it's secure.
Act 3. What light through yonder window breaks?
Let's look behind the curtains, right? Let's look through the window. Let's look at the code behind that demo. And spoiler alert, this is a library that we put on GitHub, and it is both this demo, which is completely standalone, you can run it and play around with it, but it also contains the code you need to implement this on your servers securely.
Yeah, so I will tell you why we created this library, or example project. The reason is we wanted to go and do something with ToTP, and we looked at existing implementations, both in Java and also in other languages. And what happened is we found, well, most of them were broken. There were silly mistakes in there that could be prevented. And the other thing is that, what I said before, being friendly to your user, none of them did that. So that's the reason for us to start creating this and giving these presentations, so that you at least know about this. And that you have a reference implementation. And the code's on GitHub, and if it's not up to date or if you find a bug, let us know and we'll fix it, and then all the other people also get to know the latest state of affairs.
But we were creating an account, and I'm not going to go into asking users for their preferred username and setting up passwords, because we've been doing it for a very long time and that nothing changes there. This is the first time it got interesting, right? So what we have here is the user just said, or the new user just said, this is my preferred username, this is the password I want, and now we're going to try to set up ToTP. So this is new, and we're going to look at the code that you have to write to do it.
Now, so before we do that,
yeah.
Do you know how you can easily create a QR code in your browser?
I just need to create a QR code. How would I go about it?
Do you know?
I would Google for QR code.
Yeah, and okay.
I'm pretty sure I will get to a page where I can enter stuff and it gives me a QR
Yeah,
code.
so I'm going to tell you what the result's going to be. It says, well, you can use the Google Charts APIs.
It's really
And you can just use Google API, so if on your page, just say image, and then source is, and then some URL to the Google server, where you send the data to Google, and it gives you the nice image.
It's charts.google.com/QR, URL is, and then go OTP,
Yeah.
and then we get a QR image.
Yeah.
Also,
Who thinks it is a great idea?
library as a service. It's great.
But
Yeah.
it's really naive because if you have a man in the middle.
Yeah, so there's several problems here. First, the first problem is that even if there's no man in the middle, you are
man at the end. Google.
Yeah, man at the end. You have a man at the end. Google knows about it. So that's the first problem.
Wait, it's one right. Person at the end. Google.
Yeah. So that's the first thing that goes wrong.
Very bad.
Second thing is, especially if you don't use HTTPS, then
And
all
we saw libraries that don't use HTTPS even to this code, because this code will work fine with HTTPS, Of course, it's Google,
Yeah.
and they did it in their library. And then, I mean, you have to consider if you download the security library and they make mistakes like that, you should probably throw it out because it just makes no sense.
So, if it's HTTP, it gets worse. Because not only can everyone in between see the secrets that you send to Google or some other web framework, but also if you're on a public website, open Wi-Fi connection, the rest of the world can listen in. So they all know your secret.
And if you see any request to charge.google.com flying out with OTP out in there, I pay attention.
And the last thing that's problematic here is that the Google libraries or web services, they are very, very good at caching. They make it really, really simple. If you ask for a resource, like an image, then it tells all the proxy servers, yeah, next time it's going to ask for it,
cache it,
give it. So it's not only that people in the middle can listen in, but it's also in some backups of caches, maybe on some hard disks. I don't know where, but it's out there. It's even probably on your disk on your computer. So if you use a public computer or any computer.
No, but it gets even worse because there's one more thing. Even if somehow I can tell charts.google.com don't cache it, and we use HTTPS, so there are no men in the middle. Still, your browser is going to remember which resources it looked at, even if those resources were served with no cache. So it doesn't remember the image, but it will remember the URL to the image. And in the URL is the secret, right? I don't need the QR code, I just need the secret, which is in the URL, so even that is bad. So these are also, all these things are, and this is just for making the QR code, right? And every library we looked at, or at least half of them, didn't get this right. And that's just one part. So that's one of the reasons why we said, okay, we should, do something.
So how do you do a QR code? Because that's really complicated.
Let's have a look.
There's a lot of pixels.
Oh, by the way, before I show you the code, this project has 4 packages. And the idea is, in launcher it's completely irrelevant, don't look at it, it's just so that the demo launches. It's not interesting. Then servlets, also not really interesting. It's not something you would use, but you can copy that over, you can look at it for how you would implement the stuff in your own code. Then impl is also something you can only look at for inspiration that you don't use, and the actual interesting stuff is in this package. This is the only package you would actually need in your production servers. So it's, if you're wondering like, oh, which parts are demo, which parts do I actually need, the packages will direct you for that. But let's have a look at this QR server, right? Because everything we looked at said, okay, we're gonna use charts.google.com or something else. So apparently it's really hard to make a QR code yourself. No, it's not. So what do we do here? Session management already knows the URI you want, so that's the OTP out://URL, right?
So
what do we do?
So this is a servlet, but we don't send the secret to the servlet.
No.
Because there's no need for it. We
We
only
send
say
session.
there is a
Different
secret.
secret.
There is a secret. It's stored in your session, and then we ask the session for the key.
Yeah, that doesn't matter.
And then we generate a QR code, and then we just send it.
Exactly. And now what's going on is, and this is our code, so you don't have to worry about it, but we use these sessions and we time out that code very, very quickly. So the request with get the QR code for key equals and then some different secret, sure, the browser might remember that, but in about 5 minutes, that's completely useless because we will refuse to show this QR image. You can go even a step further and say, once we render it, once stop rendering it, then of course it's a PNG, but this is also very, very important, right? Here we say, add header, cache control, no store. Very important. We're telling all the caching algorithms, all the proxy servers in the middle, the browser itself, do not cache this. And then we write the image. And that's the end of the servlet. And then generate QR code, sounds complicated. How do I, given a URI, how do I make a byte array, which is the PNG of the QR code for that URI? Very complicated. Yeah, 4-liner. There's a library called zxing, zebra crossing, which is open source, it's completely free. And we use it here, new QR code writer, encode, URI, 200 by 200, and then write it as a PNG. Done. That's all. And that's how easy it is. So, and now we have avoided all these problems that we were talking about before, eliminated them with 4 lines of code.
Okay. So how do I call this?
Right, so let's get to the servlet that, so this page, right? What's the servlet for this page? And I know we have Jersey and all these new things, but we've kept it on purpose, we kept it as simple as we can. Oh, hold on, let's do one more. So what goes on here, right? Here's the do post, right? So here the form comes in. Now this is all boring stuff that we've been doing for years. We get the username, we get the password box, and verify that you enter the right password, and then we just do did you pick the username, did you type the same password in both boxes, etc. That's obvious, we've been doing that for years. Then we do a password length check, and that's the only check we do. We don't check for exclamation marks, etc., etc., because there's no point. But then this is the only line that we actually call. It's TTP.start setup TOTP. And what's this? This is your username, and that is the name of the app. So that's what's going to show if I have my virtual dongle and I just scroll through all the various codes that I can generate with this thing. It'll just say, okay, this is the app, but it could say Gmail, World of Warcraft, etc., etc., and then username is obviously username. And that's really all you have to do. This code might look very scary, but remember that the demo shows you the code that your phone would generate. This is the code that does that. We use reflection on purpose because we don't have an API call to get that code, because there's absolutely no reason to ever get it other than for making a demo app. Right. And once we have confirmed, which is by now too late, so we'll start over.
Not the IO.
Code. It's fine. Now what happened there? That's this servlet. And what we're looking at here, so we get keys, session keys, which our system takes care of, so no problem there. Code that's what the user actually entered in the form. And now what happened here, all we have to do is call this. It's basically one call. Right, give the session, give the code. We'll take care of it. Now it's possible sessions do expire, so we have to handle that. But then what actually happens? You get a result back, and there are many, many results. It could be successful.
So keep in mind, this is the setup. We're still checking if you have the right code, but we're only checking it for setting up purposes and not for validating that you are actually you.
And security isn't too interesting here, because if, let's say, somebody's trying to set up an account on a compromised machine, we just ran the QR code of this machine, we lost the battle. So we have to assume that currently that user is who they say they are, right? They're setting up their account. So security isn't too important here. What possible results could there be? Well, it sounds like there could be success and failure, but it's actually a little bit more complicated than that. There could be success. It's possible they just entered the wrong code, but it's also possible that they entered almost the correct code, but it's too far off, right? Top mismatch. We actually handle it, and we generate a nice error message from that. You don't have to do all the math with, okay, how far should I go back? We'll take care of it for you. And there's also the option that they enter maybe 5 digits, or 4 digits, or no digits. If they do that, then it's obviously wrong, and we're going to tell them, because one thing we noticed is that users will think leading zeros aren't important, so just leave them off. And if you, for example, do this at Gmail, then Gmail just says, no, it's the wrong code, and that's it. And then users go, it's not working, and they don't use it, etc. So we've seen this, so we're actually going to tell them, hey, it should be 6 digits, make sure to enter leading zeros, because that's something we actually ran into in the real world. And that code already used can really happen when we're setting it up. And that's it. That's all you have to do. And then finally we can go for login. That would be long. Right, so let's actually go through the process. This page is actually not interesting at all, right? Because all you do is, we don't make these for you. You already have, in your existing web services, you already have a login page. All you do is generate another page. It just says, okay, well, great. I have confirmed that you are you, at least that you know what you know. You entered the right password, but I also need the code of your device. And there's nothing in this other than just generating an input field, right? So we're not going to talk about this one. But what is interesting is this form submit. How do you check it? And that's over here. And it's virtually the same thing we saw before. in that, right, we get our just one code, we'll get to code 2 and code 3 later, and the session management, and very, very similar, we just call one method. All you have to pass is the session key and the code that the user typed, and then we will tell you, alright, well, the results can be success, or they're now logged out, or they have a clock mismatch, or they just typed in the wrong code, or they didn't type 6 digits. Same thing we saw before. And we will already update the database for you, and in the database, add the marker, hey, this user now needs to enter 3 codes. Now how does the 3 code thing work? Virtually the same thing, but you just call a slightly different method, passing in all 3 codes. And this will log them in, and it will also cancel the lockout means like they have to enter 3 codes.
Yes.
Again, one call.
Yeah, so if you are looking at can I use this in my own application, I assume that you already have a login form and a registration form. How hard is it to implement? Well, we have shown you a reference implementation, and it uses a H2 database as a backend to store all the data. But that's just an implementation. But around the implementation, we've provided some interfaces. So if you
let's have a look. Right, so here I keep calling ToTP dot. What's this ToTP thing? Because we haven't talked about it yet. ToTP is an object, in this case we just pass it along. So where does it come from? This is from the launcher, which is it's literally the public 7.0 main. Right? Here we create it, it's ToTP equals new ToTP, and then what we do is we have 3 templates or 3 interfaces where, because we assume you already have a database. Right? You don't have to use our database. I assume you want it in your database so that it gets picked up by the backcode algorithm, etc., etc., etc. So what you need is we have a user store interface, a session store interface, and a crypto, which is our own thing and has no parameters at all. So let's have a look at these 2. Session store is easiest. Session store is an interface, and it only has 2 methods. It's create and get. And then you have to return a session, and what does that look like? Just get the key, put a value, and get a value. That's all. And if you want to use HTTP session management, write HTTP session, which is a thing from the service spec, you can write a wrapper around it in 5 seconds. If you have your own, you can use that. If you want to do it in memory, you can use that. Very simple. And you just give us implementations of these, and then it'll just work and we'll take care of everything. And the demo ships with implementations that use embedded databases. And finally, user store, only slightly more complicated. There's enable it. And all you have to do here is, what does that mean, right? All you have to do is store this in the database. I'm going to ask for it later, you need to give me back the same stuff. And that's all you need to give me. Get TTP data is, hey, I called this before, I need to know these 2 values, which is exactly what this object contains. And show back. And finally, we have some just mark logged out, just means, hey, you need to set a boolean that I need to know, and that they need to return there. And clear logged out is the same thing, you clear a boolean in your database. Like the implementation of this thing is pretty much a one-liner, right? Just update SQL statement, and that's it. And that's really all you have to do.
Yeah, so to recap, if you are going to implement ToTP in your application, you can write your own, you can use someone else's library, I don't care, but I would suggest that you at least look at the code of this project. It is on GitHub, and make sure that you understand every line of it, every byte.
Unfortunately, there aren't that many lines, but
there are not too many.
but
make sure that you understand everything that's in there, and maybe later check it again, check the change log, because we might have some contributions and good insights, some good feedback. You can even use this as a template, rip out the parts that give the description messages, and use these servers, and hook them to your own web server. The HTML is separated from the CSS and from JavaScript, so it's easy to add your own styling to it if you want to.
yeah, but definitely don't just pick a random library, because all the ones we looked at were, let's say, leave something to be desired.
Yeah, so don't be like Yorick. Poor
Yorick, alas,
we knew
you
him
will.
well.
That's your off project.
questions? Yes.
If you have a keylogger on your computer and they log maybe 10 events or 10 logins, how do you prevent from them taking the numbers and calculating the next ones?
So the first, they already know the password, right? Because otherwise they can't even get it. So they have that. We log out after one wrong try. And it depends, if the try could have been correct, then we log them out.
If they look at your computer, can look at your computer with a keylogger with a screen grabber or so and take maybe 10 tries of you. Like
Also they have 10 correct codes.
They have more. They have maybe 10 codes or so you used in the past,
Yeah.
and from that we can use some math to calculate the next ones.
Yeah.
So given 10 correct codes, including the times when the codes were generated, can you back out the 80-bit secret?
Yeah. Yes, you can, but it's 80 bits. So.
And the HMAC is pricey, right?
Yeah. So the calculation is not very cheap. So.
It's possible, and
I did not do the math regarding how much
No,
energy would be required to calculate that.
we are talking about like a server farm of a couple $1 million with like a year processing. Right?
Yeah.
You can do it. One problem is you can invent better algorithms. We can use PDKDF2 instead of HMAC with SSH1. But the problem is this is a standard, and if you want to change it, you can, but that means you can no longer use Google Authenticator, you can no longer order a bunch of dongles from China, you'd have to build your own house. Which, hey, if you want to go for it, more power to you, because there are a couple of other things, like another downside is you have to store a secret in your database. That's kind of annoying in the sense that if your database gets leaked, then you basically have to tell everybody, okay, so your passwords are safe, because we encrypted those with we hashed those with PDKDF or bcrypt. But your ToTP stuff, you just turn it all off because, hey, it's on the street. Anyway, that's kind of annoying. There's no way to fix it other than to change the standard. And to be perfectly fair, this current standard, even though there are a couple of these issues that could maybe be better, this is a lot if you compare it to users that just have a password and that's all.
You mentioned some token generating devices like the RSR token generator and so forth. What do you think about such devices like the YubiKey, where you have a USB device that you plug into your computer and you then just press a button on the device and it will generate a code that is automatically pasted into some kind of input form?
It's no better and no worse. It's more digits, but that's not really much secure.
Right.
And the really cool ones do have a fingerprint scanner, but then we get into the whole something you are isn't really that useful either. And now the question is the YubiKey more convenient? So these YubiKeys it's the exact same thing, but instead of having to enter the 6 digits yourself, it acts like a keyboard and it enters them for you, and even presses enter for you. Yeah, how hard is it to enter 6 digits? I would say it's a wash, it's the same thing. And it can be problematic because if you take security very seriously, you don't expose USB ports to users in practice. We don't do that, but
Maybe you can use it on your iPad.
yeah, that's true, right? Or even logging in on your own phone.
Well, that's not true. On your phone, the latest YubiKeys version support NFC, and you can basically use that.
Okay.
Just
Nice.
So then we're back to, it's kind of a wash. These things are much more expensive than physical dongles, but what we do get into is now I need a keychain with 30 YubiKeys on it.
Now, normally you can register your.
One, maybe, but then how does
I don't know.
the site
I
tell
haven't
the YubiKey doesn't know what site you're
I
trying to do.
haven't looked into
So
it.
it's, hey, if you want a more powerful, it's not less secure, but I don't think it's a general solution. And something like Gmail is unlikely to go for this, right? Because they want it, anybody can just use it, and everybody's smart. But they're definitely not worse. They're basically the same technology.
So you said it's a one-time password, and to ensure this, you save the last successful tick. But that tells me it's basically only you cannot repeat the last one.
Yeah.
It's
Or
not
any
a one-time overall time. So it doesn't say because otherwise, if you would get just a collision in the calculation.
There will be collisions.
There will be collisions.
Yeah.
And then you couldn't reuse that if it would be true one time, because then you would only also have 1 million different codes.
So it does not store the code, it stores the time.
So let's say right now.
But still, it doesn't invalidate all the codes you previously used.
That's true. Well, hold on. Let me take this from the top, right? You enter a code 1, 2, 3, 4, 5, 6. Now, what I need to do as a server, I need to say, well, the only valid codes right now are the code of the current time, the code of 30 seconds ago, the code of a minute ago, the code of 30 seconds ahead, and the code of a minute ahead. Those are the only 5 I'm going to check. Now, what we do is, we're not going to check all those 5. What I'm going to do is, okay, the current tick is, I don't know, let's say it's 1177852. That's a current tick, right? That's AMG's time divided by 30,000. When I go into my database and say, what's the last verified tick? And if it's, and I take that number and I take the current tick minus 3, and whichever one is larger, that's where I start. So if a user just logged in, and it's now 30 seconds later, I don't check 5 codes, I only check the current code, the next code, and the one after that. And that's it. So what I prevented is the code 30 seconds ago and the code a minute ago, those would have been valid normally, but because somebody logged in with them, I don't do that. So that's all. So normally you check 5 codes, right? The current one, previous, next, and next. But I might check fewer than those, depending on that tick. But that's it. Right? I check 5 codes, or 4, or 3, or 2, or 1, or if you did the 1, 2 ahead, and 30 seconds on the pause check, none, and you shouldn't have to wait 30 seconds. That's all. So we don't store code, we don't invalidate everything, it doesn't really matter. There are just 5 codes we need to check. And of those 5 codes we check, the only thing we need to make sure of is that those 5 codes that we don't accept one that was just used to log in. That's all we have to stop you from doing. And then it's fine. Because all those old codes invalidate a minute and 30 seconds after you use them automatically. We don't have to remember anything to invalidate codes that are old.
And to repeat, we are not storing the 6-digit code.
I got that. My interpretation of one time means I entered this code once and it will never be valid again. Whatever.
That's not how it works.
And that's just what I wanted.
I think like the ToTP name is just kind of inconvenient because one time it has multiple meanings.
You have a question?
If I remember correctly, you said you use some Google API?
But we don't, right?
Oh, okay, good.
Google has a charts API, and we usually say do not go there, it just generates it yourself.
Yeah, and I misheard.
A related approach to ToTP is HOTP.
Yeah. So basically HOTP is like TOTP, but the first letter is different. What I mean by that is, so instead of using time to generate new numbers to hash combined with your secret, you can also use any other source. So, for instance, I can just say, well, the first time I'm going to log in, I'm going to use the number 1, next time I'm going to use the number 2, or you can, so that's what
HTTP was first, and the idea was I get a dongle, but instead of automatically updating every 30 seconds, there's a button on it. It just says code right now. I can log in with this code. When I use it, that is, one time, right? The I'm not sure what the hash-based one is, I think. Still one time, I log in with this code, and the server verifies that it's correct, and then updates in the database, hey, that code's now been used, now we move on to code number 2. And then on my device, I press a button, go to the next code, and I can use that. That's how it started, but that button is annoying. And it's not that secure in the sense that if somebody grabs my dongle, they see the code, they just write it down, and now they can log in anytime until I try to log in. So that's kind of annoying. So the solution has been, ToTP just says, hey, why don't we just automatically smash the button every 30 seconds? And if we both do that at the same time, we got it. But that's HTTP. I haven't never seen this on like mass scale web services used. But it's the same technology.
Can we eat pizza?
Sorry, what's the question?
Can we eat pizza now?
Yeah, I'm drink beer, right?
Beer, right?
Yay!